Yeah, sure, sir. Thank you.
It's actually a pleasure and honor to you, madam. Adithi Sharma received the BTech degree in Computer Science and Engineering from Modi Institute of Technology and Sciences, Lakshmarg, India in 2008, and also qualified a GATE in 2008. She received her PhD degree from MBM Engineering College, JNVU, India, in Computer Science and Engineering. She has worked as a postdoctoral fellow in School of Engineering and Digital Sciences in University Kazakhstan in the area of intelligent crypto systems, IoT, and cloud in robotics. She is designated as Associate Professor in Department of Computer Science and Engineering at Symbiosis Institute of Technology. And she is the visiting faculty at Astana IT University, Kazakhstan, and University of EO, Nigeria. Coming to her publications, she is having more than 65 publications, including conferences and various journal papers. So she is an active member of IEEE 5G security group. Prior to that, she was worked as associate professor in Parle University, Vadodara, and she's having almost of overall experience of 15 years. She has published 65 research papers in international journals in SCI, ESCI, Scopus, and national and international conferences. She has coming to patent. She is having more than published 10 patents and having 19 patents grants in her credit. And she is also working as university examiner for Rajasthan Technical University, Kota, and Jai Narjan Vyas University, Jodhpur. She achieved many awards and scholarships, including NAO's Shakti Award by Northeastern Council, Ministry of Donor, Government of India, Parvati Chanda Devi, and Gorg scholarships and awards from Madan Lal Khurana, Sunil Dutt, and APG Abdul Kalam. She's also got the Best Teacher Award by Rajasthan Patrika Group. This is actually the introduction of the great, one of the great of Dr. Adithi Sharma. Can you please share your screen, madam, and you can continue on LLM model through generative AI, madam.
Thank you so much, sir, for such a nice introduction. And I'm thankful to organizing committee as well as Kiran sir for inviting me and giving me the opportunity to sharing my knowledge. Let me just share my screen.
Yes, madam. You can share the screen, madam.
Yeah. Is my screen visible to you?
Yes, madam. It is visible,
It's
madam. You
visible.
can. Yes, madam.
Yeah. So today my topic of the talk is LLM model through generative AI. So as this FDP is basically for the generative AI, and we all are nowadays are very much compatible with the generative AI, as well as like facing the issue, because we are an academic and we are facing the issue due to this generative AI. So I'm just introducing about the LLM model, how we can develop a small LLM model, and how can we start with the chatbots and etc. So when talking about the generative AI, so generative AI is the type of artificial intelligence technology that can provide types of content, and that can be my text and images or audios and synthetic data. So synthetic data, that is artificially generated data. So this is another challenge. So generative AI, we all are using almost chat gpt nowadays, and this is like a machine learning where we are having the unsupervised learning, and that AI tools can help explore new ideas, writing the text and getting the feedback. And we have some limitation also, that we have to keep track into the mind. So now if we want to introduce about the LLM, that is a large language model. So when we are talking about the chat gpt, so chat gpt is after first we had the like AI, and AI had another sub branch as the machine learning, that was the like analytics and the prediction phase. So it was about the first decade of 2000 that we had the machine learning, and after the various advantages and the various learning phases, machine learning was so meaningful and the powerful that it can make the predictions and automation for the specific task, and it was like impossible task into the possible task. After like 2010s, we had another branch of machine learning, AI machine learning, and then deep learning. So it was like vision and the speech phase. So it was the like revolutionary kind of things in which where we had the breakthroughs to the computer vision and the image processing, where we have introduced about the search engines and self-driving cars to classify and detect the objects, as well as the voice recognition, what is the exact human behavior we have for generating the like differentiation between the objects and the images. If I am saying cat, then how I can like predict that it is a cat or it is a dog. So my machine is also able to like face to detect whether it is a cat or it is dog. So there is like so many neural networks technology introduced in the deep learning phases. Now the thing is that generative AI, in the simple word, we can say we are after introducing deep learning, machine learning, we are now making some database, and like introducing those database, we can generate the new information, and we can what how a human can learn and introduce his thoughts in his own way. So, building an exponential increase in the size and capabilities of deep learning models, that is a generative AI, enter the language mastering phase. So it was like introducing into the 2020s, and now we are using GPT-4, GPT-5 language model, and it is using the Open AI, and it has the language-based AI application model, as this will have far-reaching consequences for business, since language parameters everything an organization does day to day, its institutional knowledge, communication, and processes. So now this is the race to release LLMs, and AI has never changed so fast. Now the thing is that when AI was moderated into the large language models before the chat GPTs, so it was since 2014, like AI introduced chatbots in 1960s. So it is not too early days that we can say that it is just recently developed the things. No, it is like in 1960s chatbots concept was introduced, and in 2014, with the introduction of generative adversarial networks or GANs, my machine learning models, so generative AI was capable to have the track of the authenticating my images, videos, and the audio of real people. So this is generating the deep fakes and another things. So here we can see it is a like rabbit and the tortoise race, where now rabbit was moving too fast, my Google bar is was moving too fast. Now it is lagging behind from the tortoise, Bing and GPT-4. So OpenAI chat GPT gen, it is like scenario of 2023, where Google shares fall by 8%. Google event in Paris predicted that Google shares fall by 8%, and an increase of open later, and then we had the increase of OpenAI and ChatGPT. Now, if we are talking about the language models, I am also talking in a language, you also communicating in the language. Language is a simply a medium of the communication. If someone want to interact, then he needs some kind of medium, and that is my language. Language is made of syntax and the grammar. Now, there is a likelihood of sequence of words, like what it may be possible the ancient of language is different. So here in the language model, when we are generating a language model, the likelihood of a sequence of words i's o of n. Okay, if I'm just saying I saw of n, So this is like just what I am saying. It is in a vocal. I often am audible.
Yes, madam.
Yeah.
Yes, madam.
So in a language models, we have to see the likelihood of a sequence of words. Like what if I am trying to say I saw N. So this is like how my English language is written by eyes of N, and it can be like in my hearing capability. I have heard the same thing. I saw a van. So these are the two different sequences which can be predicted by a human ear or a machine. So this is mainly the work of the language model. What you want to asked to predict my model. So, from the noises that came out of your mouth, both are possible. Which of these is more likely that somebody would say it? A language model is the technology which picks which of the two possible sentences is more likely. So, like probably, I saw a when is the like more having the more probability when I'm saying I saw of n, because we are habitual to hear the same thing. I saw of a win. So there are so many sentences where we can have the more likelihood to predict the different kind of sequences of a language. So language models are applied in service of language tasks we use every day. So in the language model, we have the speech recognition, finding most plausible utterance, translating, picking among possible sentences in the target language to make a fluent utterance. So when we have the speech recognition, like what my ear are capable to hear any voice, but may be possible due to the lacuna or due to the noise, I can hear another thing what I didn't say. So this is the plausible utterance. Now, after hearing those text or those vocal, we have to translate. So picking among possible sentences in the target language to make a fluent utterance. Now spelling correction. So after that, maybe possible. I have written like we have English language. Okay, not English, not Hindi. So we have English language, and I'm just writing, okay, I want this, and give me this Hindi English language. So because nowadays we are habitual to speak English language, so spelling correction helps decide likely replacement word because based on the surrounding part of a sentence. Then we have the writing as grammar correction. Now after these language models, these are the sequences or the sequences of tasks what we are using every day. Now models can generate text also, like what if we want to any text, like start with a couple of words I want. Okay, pick a high probability next word. I want, if I'm saying I want, so it is the next probability that I will say I want to, because it is like English language grammar that can be predicted by a language. Hello.
Yes, madam. You can continue, madam. No problem.
Yeah. So thank you. Pick a high probability next word, that is I want to. After that, my next probability. What will be my next probability? So it is the next word. What will be my next word? I want to eat. I want to read. I want to go. So this is the my next word probability. Yes, and this will depends on the surroundings. What is the given condition is there? If it is lunchtime, it may be I want to eat. If my language knows my introduction and I am a teacher, I want to teach, I want to learn. There are so many probabilities. But when we are saying I want, two will be the my next probability, highest probability that we have to write two. After that, in the next word, we have to pick, yes, what will be mine? Lunch, my Chinese potatoes, or something else. I want to eat aloo paratha, lunch, or my Chinese potatoes. Okay. Now we can train a simple next word model using the word of Shakespeare's, then create more Shakespeare. That is my chat GPT or my large language models. Like what my students are working, summarization of Marathi text. That there are lots of Marathi novels or Marathi newspaper. So they are trying that if we are introducing Marathi text into the language models, then how can they summarize the text? So it means we can generate more newspaper, more articles. So here, client will read me these news of price, therefore the sadness of parting, as they said, is done. This shall forbid it should be branded if renown made it empty. The above are example using a three-word window to pick a likely next word. If you use a four-word window, it ends up plagiarizing Shakespeare pretty quickly. So, when you are entering to train a simple next word model for the Shakespeare, so it is like without flag you can generate the text. But when you are using the four-word window, so it is like you can have the plagiarism when going through the plagiarism software. So this is like technological advances, that is the ability to digest or generate whole sentences and paragraphs all at once in parallel. Uses modern hardware with large numbers of compute cores in a single box. The ability for a model to be selectively aware of words that are farther away in the sentence. So I needed to go shopping, but I had lost my composer wallet. Okay, so this is like in the like schooling we have seen these type of blank sentences, and we have to go through these we have to write. Even in the exams we have some paragraphs and we have to observe, yes, what will be the suitable text. So we have used quantities of digital text for training which we didn't have before, able to partially keep track of conversation context. Now, when we are talking about the large language models, so large language models, that is like introduced with the GPT, that is generative pre-trained transformer GPT-3. For example, it is the pre-trained on a corpus of actually 45 terabytes of data, and it uses 175 billion ML parameters. When we are talking ML, DL, and then GPT, okay, LLMs. So GPT, LLMs both are combining into the generative AI, and I have talked about that. When we are talking about the LLM, we have three strategies: that what is an LLM, how they are working, and how you can introduce the business application using LLM. So here, when we are talking the generative pre-trained transformer, so it has a use data, that is 45 terabytes of data, and use ML parameters for training purpose. So that is 175 billion ML parameters. Now, if we are talking about LLMs, you can just have that it is a foundation model. It can generate human-like text. Foundation models are pre-trained on large amount of unlabeled and self-supervised data. Actually, it is the unsupervised learning, but it has the data for pre-trained as a self-supervised data, meaning the model learns from patterns in the data in a way that produces generalized and adaptable output. So when we are giving the large amount of data to the LLM, so it is like going to produce the generalizable and adaptable output. So in the LLM, it is not like now we are going for the specifications, but till now we have the generalized and adaptable output. Yes, this output maybe my for like examination purpose, text purpose, writing the articles. Large language models are instances of foundation models applied specifically to text and text like things. It is trained on large data set of tags such as books, articles, and the conversation. These models can be tens of gigabytes in size, and it is a potentially for petabytes of data, and trained on numerous amounts of text data. This is the my large language model. So if we are talking about LLMs, LLM comprises three things: mainly the data. that already we discussed about the large amount, numerous data is there, architecture and the training. When now when we are talking about the my large language model and the generative AI, so where it all comes from, GANs, LLMs and the diffusers. So maybe possible in the last 2 days talks, 2 days FDP program, you have gone through the generative adversarial networks and diffusers and what is the transformers and autoencoders. So generative adversarial networks was introduced in 2014, and the generator creates three fakes to train the discriminator. Okay, so here what we are doing, we are giving the generator noise to the generator. Now my real data is given to the discriminator. Now this noise is passed into the real data, and my generated data can be the real or fake, and it again back propagating to the generator, and again it is going to the discriminator, and it is the cycle is going on. So this is the generative adversarial networks. Now if it can maybe possible after diffusers, this is the like OpenAI 2022 example for DALI 2, teddy bears mixing sparking chemicals as mad scientists in a steampunk style. So create images from text by denoising. So you can create any image by denoising the things. So here you can see these you can when a scientist is doing an experiment, he is wearing some such type of glasses and their clothes and all, and now my teddy bear is also able to wear all those things. And maybe possible after deep fake, when generative adversarial network is working, so after the feature extraction, you can generate the fake images of the real entity. So this person in real doesn't exist. In the large language models perform sequence to sequence predictions and generate the next word in a sentence. So this is the transformer network since 2018. So we are recite the first law of robotics. So input and output, and then we are generating such type of numerous data that you cannot think in a such a way that it can be my text or it may be my image. So till 2048, a large language model will be capable to have the next word unimaginary imaginary into the text. So large language model having the data, that is numerous amount of text data that goes into these things. Architecture, this is a neural network, and for GPT that is a transformer. So it may be of neural network or it is a transformer. And transformer architecture enables model to handle sequences of data like sentences or lines of code. And transformers are designed to understand the context of each word in a sentence by considering it in relation to every other word. So, this allows the model to build a comprehensive understanding of the sentence structure and the meanings of the words within it. So, when we are talking about the architecture, we can have some type of transformers and the GPT or neural network. So, so that we can have the each word in a relation for considering next to a generation text. So this model is when we are having to generate some text, so this model is a comprehensive guide for the sentence structure and meanings of the words within data. You can imagine how much data we have to train, and we have to have my database. So training, the model learns to predict the next word in a sentence. So the sky is. So the sky is blue. We all know that the sky is blue. The sky is green, we never read. So my how my training is done, it starts off with a random guess. The sky is bug, but with each iteration, the model adjusts its internal parameters to reduce the difference between its predictions and the actual outcome. So there are so many predictions to have the actual outcomes, and the model keeps doing this, gradually improving its word predictions until it can reliably generate coherent sentences. Forget about bug, it can figure out it is blue. Now the model can be fine tuned on a smaller, more specific data set. So here the model refines its understanding to be able to perform this specific task more accurately. Fine tuning is what allows a general language model to become an expert at a specific task. So we are having like data architecture and training. Now after the training, the sky is bug. Okay, my model has predicted that sky is bug, and after several like iteration we have done, the sky is blue. So after like now this is the sky is blue, it has cloud are rainy or not rainy. So for these things we have to define the specific task more accurately, and this is the like fine tuning that allows a general language model to become an expert at a specific task. Now, chat gpt from openai, how this was trained. So these are the like step 1, step 2, and step 3. So in step 1, collect demonstration data and train a supervised policy. In step 2, we have to collect comparison data and train a reward model. And because it is a reinforcement model, so step 3, optimize a policy against the reward model using the PPO reinforcement learning model algorithm. So in step 1, when we are talking, collect demonstration data and train a supervised policy. You all know supervised policy is the label data. So a prompt is sampled from our prompt data set. Explain reinforcement learning to a 6-year old is student or kid. A leveler demonstrate the desired output behavior. We give treats and punishment to teach. This data is used to fine tune GPT 3.5 with supervised learning. So after the teaching, we have to supervised learning fine tuning process in GPT 3.5. This is my OpenAI data, where we have the demonstrated data and the supervised policy. Now in the step 2, what we are having, we are collecting the comparison data and training a reward model. In comparison data, a prompt and several output model outputs are sampled. Explain reinforcement learning to a 6-year-old. In reinforcement learning, it is the agent, and there is explaining the reward. And in machine learning, we give treats and punishment to teach. So here a leveler ranks the outputs from the best to worst. So in the best, if we have D as the best and C, A, B, and B is the worst. So this data is used to train our reward model. Bug to blue, there will be so many tags. It may be bug, bat, and there are so many words which is going to identify blue. So this is like my reinforcement machine learning is working to train our reward model. Now in the step 3, optimize a policy against the reward model using the PPO reinforcement learning algorithm. So write a story about otters. Okay, a new prompt is sampled from the data set. A PPO model is initialized from the supervised policy. So after that, once upon a time, the policy generates an output and the reward model calculates a reward for the output. And after that, the reward is used to update the policy using PPO. So this is like how my prompt model is working through this supervised policy and getting the rank to update the policy using PPO. So it was like Chat GPT was designed from the OpenAI during the training. ChatGPT 3 training corpora getting good examples. So if we have some data set like common crawl that has the quantity of tokens as the 410 billion, weight in training mix is like 60%, epochs are like for 300 billion tokens, that is 0.44. For web tax 2 it is 19 billion tokens and weight in training mix is 22%, and we have 2.9 epoch syllabs when training for 300 million tokens. And um, data set of Wikipedia has the less number of tokens, that is 3 billion. Weight in training mix is 3% and 3.4 epochs elapsed when training for 300 billion tech token. So what exactly is the weight in training mix? It refers to the fraction of examples during training that are drawn from a given data set, which we intentionally do not make proportional to the size of the dataset. As a result, when we train for 300 billion tokens, some datasets are seen up to 3.4 times during training, while other datasets are seen less than once. So you can see in the Wikipedia we have the 3.4 times during training. So this example was taken from the Brown and Tom, and language models have few short learners. So here we have the lots of text for the known universe of topics and words. It's not just having the Shakespeare, it has million of tags, billion of tags. Accurate text more likely that combination of words. True facts: Wikipedia collection of books, edited volumes, are believed most accurate. The web crawl was filtered for sites similar to known accurate sources, oversample Wikipedia, and better book collection, undersample general web. But still generated taxes using putting words together. So this is like just as an example I have taken, just this example. When we are in the real journal, we have table of contents and this, and maybe possible after getting this kind of text, now it is the generating the fake data factors influencing the growth of a small and medium Ghana, and there is no such Google Scholar paper. So it is generating the exact e-public repository PDF and references abstract, but this is not actual data. Now what is the next? That is my video. Okay, so still we are working on the text and the images, and Google imagine video with prompt teddy bear washing the dishes. Okay, so here you can see that it is exactly my teddy bear is washing the dishes. Taking stock LLMs today. So the difference between speaking and thinking, the human brain could explain why AI programs are so good at writing grammatically superb nonsense. Okay, capabilities in a nutshell, that is statistical text prediction, impressive text generation capabilities, interesting application scenarios if carefully controlled. Caveats in the nutshell: foundation models are expensive to build and run, built from largely uncurated training data, no control over output quality, and this is the hallucinations and the bias. Outputs must be validated. So if my uh, LLMs are generating some outputs, so it is not validated. You cannot say this is the exact data what we want. That is not having the accuracy. So, Gen AI use cases, guiding principle difficult to create but easy to check. Code, text sequence, task sequences, short tests, that is my copywriting, document search, summarization, templated text, and contribute to complete text and complex text, image, video creation, and editing. So in the business application, we have the customer service application, software development, create intelligent chatbots so that it can handle a variety of customer queries, content creation, to write articles, to write research papers, to write some paragraph or news or something else. Now, ethical checks. So, how was the Gen AI built? Curation of training data. It has bias been addressed, good quality or relevant. performance benchmarks, how good useful is the Gen AI. See, this is dependent on the text and the data, what data set you are feeding. If you are developing right now, in future it will be useful or not. So article sourcing, what cheap labor involved, has copyright being breached, carbon footprint, how much compute was used to build it and how much will be required to run it. Now this is the AI mediated communication, many opportunity, but how do we embed trust? Now, if we have actual camera image, reconstructed image, you can see the features are having the transmit embedding. And now we can select any image generator. There are so many tools which has now AI vocal help, and you can have as a model and generate any kind of song and tune this song with your voice. So it is like whether it's one person or 100, it is just reading a script. So Nvidia Maxine reinventing real time video communication with AI. So this is like selecting any language synthesizer, and it can generate any kind of voice. It may speak Russian, Chinese, French, Japanese. If I'm speaking in English, I can speak many languages in a while. Now the dark house of Gen AI. So this is scientific discovery, optimization, and the configuration. So there is a alpha tensor, DeepMind's alpha tensor, that has discovered more efficient matrix multiplication, and DeepMind's AlphaFold and Meta's evolutionary scale modeling predict 3D shape of proteins, and Yosha Bengino generative flow networks, that is generative toolkits for scientific discovery, that is going to develop with the IBM. So making LLM bigger and bigger will lead to AGI, artificial generative AI. So no, it won't. AI and the limits of language. An AI system trained on words and sentences alone will never approximate human understanding. So human understanding is always a use, having the always use capability. A system trained on language alone will never approximate human intelligence, even if trained from now until the heat that of the universe. So it was given by the Yan Lechun in 2022. The AI control problem, we need effective guardrails. So if controlling an LLM means making it provide accurate, truthful, the appropriate response to questions, then they are all out of control. Developers don't understand the deep networks they build. Too much alchemy, not enough science and engineering. The tech industry needs to be better, implement guardrails, and be open about the data used for training. We need more well-funded, dedicated AI safety search. Future innovation will come from open source. There are massive efforts underway in making models smaller and more efficient. The future is combining model, so this will harder to control. And now we have the impact of Gen AI. We are witnessing an unprecedented social experiment on a global scale. If you want it or not, we need it to get our head around Gen AI, because we all will be exposed to it. Like what in academics we are making setting the question papers. Okay, now before having anything, we are just opening the chat GPT. Before this era, we are using the books and the my materials for getting the question paper built. But now, because this is like we have the exposure, so we are using this. So Gen AI will change the way we create and consume the information. We need to encourage responsible use of Gen AI. We need a debate to support the creation of helping regulatory frameworks. So in the last and the most conclusion, the large language models are an astonishing advances in language processing. They grew from a technology which we use every day in speech recognition, spelling correction, where we few people questions their utility or benefits. We generally regard language as the representation of thought. Every paragraph is a thought that went through somebody's mind as they wrote it. But the thought in these model is what the most plausible string of words it can say. So thank you. If there is any query.
Any queries from the participants? You can interact with ma'am. Any queries? Is there any queries? Is there any queries? No.
No.
Okay, ma'am.
Yeah, thank you.
Okay, madam. Actually, we are very much pleased to have you here, madam. And the topics which you have discussed, that are LLMs and GANs and diffusers. Those are actually which are helpful for the faculty members and also the research scholars, madam. Actually, these topics are very, very useful topics, madam. And you are also explained about how Chat GPT from OpenAI was trained. That was an excellent topic, madam. So I would like to say a warm on behalf of Shri Vishnu Engineering College for Women to convey my gratitude to Dr. Adithi Sharma. Deserves a special recognition for accepting our invitation and being here with us today, madam, for sparing your valuable time here and sharing a valuable thoughts about generative AI, madam. Once again, we are very happy and thank you, madam.
Thank you so much, sir. I have one question in chat window, that is Professor Nasir Darani. So, do you think LLM models, especially BERT, SkipGram, and SIBO through AI, will be able to change our e-learning in the new future in order to develop new knowledge? See, knowledge is something different what we are generating right now. So we cannot say that these model are able to generate new knowledge. New knowledge is making innovations. So this is like scaling up. Scaling is okay, but not new knowledge.
Yes, madam. Yes, madam. Thank you, madam. Thank you for your
Thank
valuable words, madam.
you. May I leave, sir?
Yes, madam, you can leave, madam. Thank you, madam.
Thank you.
Thank you, madam.
Thank you very much, madam. Sir, dear participants, please be in line. We will have Dr. S. Brilli Sangeeta, madam, within few seconds.